Again, we're over in the middle of page 3, where we stopped yesterday. We're going to chat for a moment, do a quick review of standard form, and then we're going to jump to form number 2, which is vertex form. The easiest form to deal with. Shoot, we're not going to need a calculator on this at all even. But this is going to be our key to being able to make those 2 equations that we skipped yesterday. Because I wanted to do it the easier way and the way that we'd probably do it moving ahead. So, let's get down to business. Okay. F of x, there it is. ax squared plus bx plus c. Standard form. If a is positive, we're heading up. We have a bid. Okay. It opens down if a is negative. There's our hill. A maximum. Okay. All these things interconnect with each other. The thing that we didn't really talk about yesterday, because we didn't get to see it in action very much, but we will today, is, here comes all these fancy words again. When does my graph get wider? When does my graph get skinnier? Vertical compress. Because if you compress something, you smash it down. If you smash down a tin can or an aluminum can, like it kind of gets wider a little bit as it gets down. That's going to happen when your A value, I'll explain why I'm going the absolute value route here, is between 0 and 1. The width doesn't matter on if it's positive or negative. That just determines open, up or down. Whether it's getting wider or not just has to do with whatever the A value is. So negative 1/2 or positive 1/2, it's the same thing. They're both going to be getting wider. So basically, if it's a fraction, okay, most of the time, that means it's going to be wider. However, if that A value is greater than 1, its absolute value, that graph's going to get skinnier. It's going to be vertically stretched. So the bigger that A value is, the more it stretches up and it's getting skinnier as it goes. Doing that. So just a couple of things to keep in mind. That's going to be true with all the forms that we look at. So today, oh my gosh, this H and K stuff is back again. We've had it with the square root functions. We've had it with absolute value functions. Now we have it again here with this. So this is getting to be normal. My vertex, the center of my graph, is going to be HK. Be careful. See how that's the opposite of H? So whatever you see in the parentheses, it's always going to be the opposite of that for your vertex. So something to be aware of. And then your axis of symmetry is the H value as well. So just like in standard form, if you find one, you have them both. So that is a consistency that we're going to see throughout with these. So check this out. This is going to be awesome. I'm going to teach you a pattern with this too, and it's going to be great. So, my vertex is the opposite of H and K. That's it. 2, -4. My axis of symmetry is just the X value of my vertex. So you're like, okay, well now, how do I graph it? Okay, this is where I'm going to show you something on the calculator at first, but we're not going to need it for very long. I'm telling you. The non-calculator way is so much better. Okay, so I get it in. I hit graph just because I want to see if I'm on the right track. So 2, -4, yep, looking good. Pull up my chart. I'm going to get my 2, -4 in the middle. Am I going to see my symmetry? I am. Awesome. So in this case, I just want you to go ahead and plot the points that you see in the chart. Because so far, we don't know how this works yet. Can I get any more? I actually can. Okay. That's simple enough. I mean, and again, these are parabolas, not absolute values. So we're trying our best to at least give them some curve. That'd be nice. You're like, that's it. That's it. That's it for now. Because I haven't shown you the pattern yet. But I will after we do number 10. So I look at number 10 and I'm like, okay, vertex, opposite of H, keep my K. We're not changing them both. This is not a circle. Get my dot there. My axis of symmetry matches the x value of my vertex. So let's play with the calculator one more time. Then I will share my secret. Kind of see, let's see if my vertex looks like it's in the right spot. -3, 1. Okay, that's good. Let me pull my chart. Get my -3, 1 in the middle here. Okay. So -4, +3. I'm not going to be able to fit in this -1, 9 and stuff, so I guess we're just going to go with 3 points here. But I am going to do something on this one. This one, I'm going to make me a little chart. And I'm going to put my vertex in the middle. And I just want to get a couple of values going each way. I want you to be able to see something here in a minute. So let me get just a couple on each side of my vertex. And I'm actually going to come back for just a moment and do it here as well, because I want you to be able to see all the things. So just a sec, so you don't think I'm up to no good here. I am good and ready to go. So we'll get that 2, -4 in the middle here. 1, -3, 3, -3, 0, 0, 4, 0. Okay, why am I making these little charts? Because there's a pattern when you're graphing in vertex form that is going to help immensely when you're trying to graph these and not have to do all this calculator and table. You can, but I'm just going to show you something that's easier. There's this thing, and we're going to talk in depth about it in a little bit here. There's this pattern when you're finding the slope, in quotes, it's not real slope, these aren't lines, called 135. And what that is that your A value, if it's just 1, like it is in number 9, check this out. If I start from the vertex, and I go up 1 and over 1 each way, okay, there's my first dots. That's the 1. Then from those dots, I go up 1, 2, 3, and over 1. There's the 3 in my next pattern. 1, 2, 3, 4, 5. Out I go. So what that lets me do is, once I have my vertex, if my A value is 1, I'm just going to go up 1, whoop, up 3, whoop, up 5, whoop, and make my points. If it's not 1, if it's 2, like it is here, here's what I'm going to do. I'm going to take that 1, 3, 5 pattern, and I'm going to multiply all of them by 2, because that's what A tells me to do. So check this out. There's my vertex. How do I get to my first dots? I went up 1, 2, and went out, just like I was supposed to. If my graph would have been tall enough, which is why I put the chart up this time, how far is it to get from 3 to 9? 6. The pattern is always there. The 1, 3, 5, you just multiply it by whatever that A value is. Now again, I'm not taking the calculator from you yet, okay? But for the time being, start to play with that a bit. Now this gets a little bit funky. I'm going to admit it. let me ask this before we get too far. What's my vertex on this one? Nice. -1, 3. My axis of symmetry is at -1. You're like, Hardy, half. -1/2 even. That's nasty. Okay. I'll show you on the calculator too. If I multiply each of these by -1/2, ew. How am I supposed to graph those? So here's the thing with that. If I go down 1/2 and over 1 each way, and then I go down 1.5 and over 1, down 1.5 and over 1. It's doable. 1, 2.5 over 1. 1, 2.5 over 1. Now I'll show you. Because maybe some of you, when you get to fractions, are going to be like, Hardy, I'll do the pattern on a normal one. I am not doing that on no fraction. So let's see if the pattern shows up anyway. Let's give it a shot. So there's my vertex. My vertex is at -1, 3. Okay, there it is. So we did that right. Check it out. -2, 2.5. There it is. Okay. 0, 2.5. There it is. 1, 1. -3, 1. So I can get 4, -1.5 to -1.5. The pattern works, but again, my calculator's there for me. If I need that security, that's never going to be a problem. Okay. So you have multiple options now, especially when you're in vertex form. If you're in standard form, you can do this pattern still once you have the vertex. Just use your A value and let it kind of do its thing. So, okay. One last little piece here as we're going along. You're like, no. Oh, applications, crud. All right. These are not going to be bad at all. The one thing we're going to have to figure out is what the questions are asking. So here we go. Here's your application for those of you that are always asking, when am I ever going to use this? Well, here's a possible opportunity. A souvenir shop sells about 200 coffee mugs a month for $6 each. The shop owner estimates that for each 50-cent increase in price, he will sell about 10 fewer coffee mugs per month. Okay, how much should the owner charge for each mug? How am I supposed to figure this out? All right, here's what we're going to do. Notice I have two numbers in here that talk specifically about the number of mugs. And I have two numbers in here that talk specifically about prices. Okay, we're going to make a mini little piece of our equation out of each of those. So here's how that works. Let's start with the blue here. I'm selling about 200 coffee mugs, okay? So 200 of those. I will sell about 10 fewer per month if I increase the price. Okay, I don't know how many I'm going to get as I move ahead. But I just know for every time I increase the price, I'm going to sell 10 less. So I got to get X'd in with that second part. And I'm going to do the same thing with the second part. Right now I'm selling them for $6, but I'm going to increase the price by 50 cents each time. So for each increase, which is a variable, we're going to have X. We have to multiply this out. Okay, we need to FOIL this out because I need to see it in standard form so I can get some information. So if I FOIL it out, so I got my first, I got my outer, so half of 200 is 100. My inner, 6 times -10 is -60. and my last. Half of negative 10 is negative 5x squared. X times x. Details that we got to watch for. And so when I rewrite this now in its final form, I want it in standard form. Standard form again, ax squared, so my x squared term goes first, plus bx, my x's go next, they are combined, and my constant term goes last. This equation, this quadratic, will tell me what I should do. How many mugs should I sell? What should I sell them for? It's going to give me all the info I need. So here's how this works. How much should the owner charge to maximize their sales? Remember, we're going to be looking here. Now, well, I'm not going to do that yet. You didn't see that. I don't want you thinking ahead on this. So I'm looking and I'm going, okay, so what am I trying to find? Let's be visual this first time because we don't know quite what we're getting into yet. This will not fit on your regular screen with that plus 1200. So remember, if we do zoom fit, zoom 0, we should, hopefully if the calculator cooperates today, okay, so I can see my maximum up here. It's going to be way up there. Do I want to be messing with the calculator trying to figure this out, scrolling up? No. We're going to go back to our formula for this, our little mini formula, our little negative b over 2a. There's my b. There's my a. Okay, the x isn't telling me how much to increase the price. It's telling me how many increases should I make to my price. So I should make 4 times how much each increase is. So we're telling you, or the math is telling the owner, hey, you need to increase the price of your mugs by $2 each, which means if I'm currently charging $6 and I add this $2 increase, I should be charging $8 a piece. But here's the good news. That's the last part of the math I need to go looking for. Because what did I just find? I just found the x value at my vertex. So now I can get cute and say, okay, so if I have got, I want to get one thing over here, I can look and I can say, okay, I still am I'm going to do this algebraically once because I want us to see this. I'm going to take my y. I'm going to plug in the 8. Again, we have options, which I will show. So I'm going to go ahead here. Ooh, now wait, did I just... Oh, I almost did it bad. I caught myself. Anybody know why putting 8 in would have been bad? What was the x value I found? Okay. I almost did it bad. I got too far ahead of myself. So we're going to fix that. See why the mathematicians that deal like the accountants and stuff with businesses, why they make so much? Because there's a lot of stuff we got to be careful of, which I almost wasn't there. Almost. So the maximum monthly income that the owner can expect to make would be $1,280. So you would have to go about. Now, could I have, you're like, Hardy, why do you do these things to us? Could I have gone to my calculator, since what I knew now the x value of the vertex was, and just gone in and gone to y? Yep. Okay. So again, or use. We can use the chart. It's not going to be a bad thing. Okay. These problems all set up that way every single time. You're going to have two different things, usually money and then a quantity that you're just going to put in. You're going to multiply it through. You are going to have to find the mini formula to find your x. There's really not going to be a way around that unless you get cute with the calculator, but we'll see about that. But then make sure it's the x value you plug back in or that you use it in your chart to get there. Otherwise, you know, it can get a little screwy. And I'm purposefully going to save one of these for when we either review for the graphing quiz or when we're working, getting ready for a work day, because I want to have a second one to go through with everybody once you've had a chance to look. That finally puts a wrap on that first part, which gets us to the easy part. Thank God. It needs to be an easy part somewhere. So we're leaving that open. Okay, now I'm going to double back on some things that I've said, because there's a lot of stuff to keep track of. So again, when we talk about our A value, we're not talking about normal slope. Slope makes a line, okay? When we're doing this, again, in a linear function, a line, the slope's the same all the time, no matter where you go. When we're doing a quadratic, it's not going to be the same all the time. It's not going to be constant. Now, do I need to go through all this crazy? No, what I need to show you is what's right here that we already started talking about. When you're working with a parabola, it goes up in increments naturally of 1, then 3, then 5, then 7, and it just keeps going on that pace forever and ever and ever. The only ones we typically deal with are 1, 3, and 5, because otherwise they get off our graph. They're too big. So again, if your A value is 1, the pattern is 1, 3, 5. That will not change, okay? But, as we saw in the other one, if your A value changes, all you have to do is multiply it by the 1 and the 3 and the 5. And again, you'll go up to and over 1 both ways. That's again why it's not like slope. We're not going one direction. We're doing both. And then you start from these. You go up 6 and over 1 both ways. Up 10 and over 1 both ways. Once you have your vertex plotted. Plot the vertex, go the pattern, you're done. Gosh, that's easier than find the x, find the y, plug it in, make a chart. Who wants to do all that? So working with this pattern instead of just depending on the electronics is something that we want to make sure is good. Fastest note page ever, right? Especially when we chatted a little bit. Okay, fractions, we even saw those already. This is great. We saw 1/2 where we multiplied through, and we saw, yes, sometimes we're going to be in the middle of lines when we're graphing these. That's going to happen, and that's okay. But a lot of times we're going to get back to whole numbers fairly quickly. You always have the chart as a backup if you need it. So, we're going to do one of these because, again, I don't want to go flying along and just gibber the whole time. I want you to actually see how this works. So, let's try out number 1 here. Where's my vertex for number 1? -2, -4. Okay, so we got the first one there. My A value is -3. So instead of 135, oh, I wish I'd have changed that. Can I change it now and get away with it? I'm going to. We're going to make a quick change here because I want you to be able to see the pattern over here better. We're going to make this +4. You're like, Hardy, you should have made this decision 30 seconds ago. Well, you know. All right, that's not there. We don't see it. Here's my pattern. There's my A value. Multiply your A times each number in the pattern. Now, it's rare. Maybe we'll make -15 fit on anything. But here, this is your up or down. The over number is always 1. So we're going to go down 3 and over 1 each direction. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1 in each direction. Done. Now again, this is here, okay? It's there, but speed-wise, once you start to see what the pattern is, this is going to be faster for those of you who are time crunched. So I just want you to think that through a little bit. Do I have one more piece left in me? I got one little piece left in me, I think. Yep. I'm good with this. We're going to knock this out, then we're going to be done. We're going to cut again. Again, as I had at the beginning, I thank you for your patience on this. All right, last thing to play. More applications. Okay. A rocket is launched for you future aeronautical, almost said astronauts too, people. A rocket is launched directly upward at 80 feet per second from a platform 112 feet high and is given by this equation. Okay. What is the initial velocity of the object when it's initially launched? Okay, let's... Okay. When they give you that opening speed on any of these, okay, that's your initial velocity every time. So our initial velocity here would be 80 feet per second. Okay, no calculating there. Just stripping it straight from the problem. Or even if I was just given this, it's the number in front of t or x, whatever happens to be there. What will be the object's maximum height? Maximum height. What's the y value of the vertex? So here, I kind of got to play around with this a little bit. So, because then I also read, I'm going to read the next question too. How many seconds have elapsed when this height will be reached? How many seconds is always the x value of your vertex. Now, we wish that this was in vertex form. That would make this easier, but it's not. So I just do a little A, B, and C action here. And we're like, all right, so x is the opposite of b over 2a. That is not going to come out clean. So let's do -80 divided by -32. 2.5. 2.5 seconds. So we know the trick now. Once I know this, okay, what will be the object's maximum height? Hang on, Hardy, I got this. I could just plug 2.5 in for each of those t's. That's fine. I probably should call this t. Otherwise, this again is why we mess with this stuff, because that's what's going to make it easier as we go. I'm going to put in x instead of t, because that's what the calculator likes. So remember from yesterday, if I do a chart right now, currently we don't know how to adjust this unless we mess with a bunch of things. We'll get to that. But for now, if you just hit trace give us a moment here. I don't like that that's not where it belongs. I'm putting this back in standard form. Okay. So you're like, Hardy, I can't see the vertex. It's like way up here somewhere. That's okay, because if I hit trace, I can punch this value in, and it will tell me what the y value is going to be, which is 212. So we're just using trace and 2.5. Not too rough. And then show the heights for the following times. I'm just going to pull up my chart. And for each one of those times, I'm just going to fill in the value. How far are we going here? Straight off my chart. And then it says, find the average rate of change, not quite slope as we think of it, in height from t equals 1 to t equals 2, from t3 to t5. We're still going to calculate the rate of change like you would if you were doing slope. Time is always your x, height is always your y. Because if you think about it on a graph, the height is going up and down like the y-axis does, and the time would be going from left to right like your x would. So when we're doing rate of change, remember, it's subtract your y's over subtract your x's, or we could use, delta, the little triangle there. So from t equals 2 to t equals 1, it's my x's. So if I do 2 minus 1, remember when you're doing slope, you got to do the y's in the same order. So I started with 2, so I'll do 208 minus 176. And let's see, that's 32 over 1, or 32. 32 feet per second is the speed at which that rocket is going over that time, because it's not going to be the same depending on what times we're looking at. So when we do t3 to 5, I do the same thing. The y value at 5 we start with. The y value at 3. This is looking a little funky. So is it possible to have, a negative rate of change? Sure. Because think about the rocket, when it's going up, it's increasing in speed at that rate. It's going to get to its maximum up here at the top, and then it's going to start its free fall back to the ground. So that's just telling me, hey, between these periods, it's already hit its maximum. It's on its way back down. And I can see that because we kind of knew already it hit its peak at 2.5. Whew! Okay. Finally made it through the first section here. Holy moly. Tomorrow is extremely short on the lesson. You're like, hallelujah, we need some time here, dude. So, you kind of have an idea what the plan is going to be here now. So here's what we can do at this point. And again, take things in pieces. You don't have to go cray-cray. So now we can do page 2 because we understand vertex form. We've got an example of the application there. Everything else is just a little bit of review. Nothing terrible. It's a handful of problems. And then we can start, and I'm going to put a note on here. I'm just looking. Yep, that's what I'm going to do. Okay, when you're on pages 3 and 4, I want you to do a minimum of the odds. You're like, don't you always say that? Yes, but here especially, because the odds, it's going to give you 2 of the application problems instead of 1. You probably we'll get enough of an idea using your A value and your vertex to get the graphing down, only doing 3. But if you do the first 3, check your answers. And make sure that it's going right. If it's not, try a couple of evens. You have access to the answers and the pictures. Okay? We're looking towards the end of next week for the graphing quiz. Probably Thursday, Friday-ish, since we don't have school Monday. But do people practice, practice, practice. Ask me questions. I swear I will not yell